Hi students, welcome to the ACE online platform. Happy New Year. So, as you all aware the fact that we are dealing with numerical answer type questions and multiple select questions in the GATE 2026 Score Booster Series. So, this is a session which is targeted for the electrical engineering students who are preparing for the GATE 2026. So, here we are going to focus on electromagnetic theory or electromagnetic fields. Fine. So, here just check out how many students are active. See here, regarding this subject, frankly speaking, most of the students are not comfortable, and that too they are undermining this subject. But remember, if you observe the previous papers, if you observe the trend, and one more thing is interesting fact about this subject is in before 2015 it was not a separate subject in your syllabus. It used to be included as a part of your networks, but in the year after 2015 it was introduced as a separate syllabus. And right from the inception, if you observe the previous papers, he is keep on increasing the weightage. In the GATE exam, even you can expect up to 4 marks, up to 6 marks. So you know, if you wanted to have a selection, fine. If you wanted to get a good number in the GATE paper, this is a subject which you cannot avoid. Okay. And one more thing here our interest is only our exam. We are not here to do any research in this subject. So the questions asked in the previous papers, questions asked in the GATE exam can be answered. Of course, this subject may be a pure mathematical in nature, may require some lot of visualization, but our interest is only our exam. Fine. So prepare well, plan well for this subject. Anyhow, so we're going to start with the numerical answer type questions and MSQ questions related to this one. So the questions what I'll going to deal, so I'll try to cover all the topics. Fine. So let us start. So here is a question here. So this is question on the charge distribution. So there are different charge distributions: line charge distribution, surface charge distribution, volume charge distribution. So it's a very popular question. Fine. So that too we have considered it as a uniform charge distribution here. Now a uniform volume charge density of 10 microcoulomb per meter cube is presented in the spherical shell. So where R is ranging from 0.1 to 0.9 to 0.1 meters, and the rho v is equal to 0 elsewhere. The total charge present is dash microcoulombs. So how do you find out the total charge? As it is a constant, you can just multiply with the volume. That can be expected for 1 mark. Okay. So the total charge Q is equal to volume integral of rho v into dv, or you can also write it like this. So here this is a constant, 10 into 10 to the power of minus 6 into dv, it is r square sine theta dr d theta d phi. Now bring the constant outside and separate out the variables. So it is 10 into 10 to the power of minus 6 into r square dr sine theta d theta. This one is d phi. So it is 10 into 10 to the power of minus 6 r cube by 3. R limits are from 0.9 to 1. So it is minus cos theta. Theta limits are from, for the sphere it is from 0 to pi. Yes. And here it is phi. The limits are from 0 to 2 pi. Substitute upper limit minus lower limit. Yes. Any students online? Keep giving your answers. So I'll go into cross check them. Okay guys, so substitute upper limit minus lower limit here. So it is 10 into 10 to the power of minus 6 into, it is 1 minus 0.9 cube by 3 into minus of minus 1 minus 1 into 2 pi. So we're going to get an answer in nano, not nano, micro. Fine. So here is a charge Q. You can check out, this value will turn out to be, my calculator is showing it is 11.35 microcoulombs. So 11.35 is the answer. Clear, guys? So it is a numerical answer type question. Fine, done. So let me turn the page here. So we're going to take up this question. This question is related to the Gauss law. The questions on the Gauss law and questions on Ampere's law are very popular. Fine. So there are three different forms. One is a definition form, integral form, and differential form. Clear? So those three forms are very important. Just a second. Okay, guys, let us proceed further. So here is a question. So if D, that means it is the electric flux density, D is equal to 10 y square x cap plus 10 x square y cap plus 15 into z cap millicoulomb per meter square. The total charge enclosed within the region x comma y comma z ranging from 0 to 2 meters is. Yes. So here you can make use of what is called Gauss law. You can answer this one in two steps. First, in the first step, find out the divergence of D. It is a volume charge, right? So after that, you can find out the total charge. This is how you can think, or you can also think in terms of the definition of the Gauss law. Fine. Anyhow, the mathematical procedure remains same. So it is a Cartesian coordinate system. Dou by dou x of it is a 10 y square plus dou by dou y of 10 x square y plus dou by dou z of it is 15. So this will become 0 plus 10x square plus 0. So rho v is equal to divergence of D, which is equal to 10x square millicoulomb per meter square, meter cube. It is a volume charge. Then you want a total charge. For the total charge, you need to perform the volume integral. So it is rho v into dv. Substitute everything here. 10x square dx dy dz. Separate out the variables here. So you can bring the constant outside. It is x square into dx dy dz. Okay. So it is 10 x cube by 3. X limits are from 0 to 2. It is a y, limits are from 0 to 2. This is a z, limits are from 0 to 2. Substitute upper limit minus lower limit. It is 10 by 3 into this is into 2 into 2. So you can check out this value. This value is 106.66 millicoulombs. Everything is in terms of milli. Am I correct, guys? So it is the millicoulombs. So we'll go to the next question. Yes. Here is a question, MSQ question. Something interesting. A line charge of density 24 nanocoulomb per meter is located in the free space on the line y is equal to 1, z is equal to 2. First part is the magnitude of the electric field intensity at 6 comma minus 1 comma 3 is this one, the magnitude, and the second one, the magnitude of the electric field intensity at 6 comma minus 1 comma 3 is this one. Point charge of minus 4.43 microcoulombs located at minus 3 comma 4 comma 1 to cause Ey to be 0 at a point P. So this point P, at this point Ey to be 0, at some location the point charge is located, and so on, the last statement. Let me turn the page here. Let us have some rough diagram for this. So where that infinite uniform line charge is located, y is equal to 1, z is equal to 2. So it is parallel to x axis. Fine. So let me take the coordinate system like this. This is x, this is y, this is z. Y is equal to 1, z is equal to 2, 1, 2. So let me make some box out of this for the 3D visualization. So this is how the infinite uniform line charge is located. It is something like this. Okay. So what is the charge on this? The charge on this one is 24 nanocoulombs. This one is 24 nanocoulomb per meter. So this is represented with the rho L. Okay, fine. So what is this point? This point is, so it is 0, 1, 2. So this point is x, 1, 2. So what is changing on the line? X value is changing. Y and Z are fixed. Okay, fine. So it's asking what is the electric field? What is the magnitude of the electric field at a point 6, 1, this one. So what is the formula to find out the electric field due to infinite uniform line charge? It is rho L divided by 2 pi epsilon rho cap. So this can be written as rho L divided by 2 pi epsilon naught. This unit vector can be written as vector by its magnitude. So vector by its magnitude square. Okay. So it's asking at a point. At what point is asking? The field point. So the field point here is asking at 6, minus 1, 3. 6, minus 1, 3. So it is 6, minus 1, 3. So what is its corresponding perpendicular source point? It is x, 1, 2. So to get a perpendicular distance, I need a perpendicular distance vector. Yes. So I should maintain the same 86.37 z cap. So this is the electric field, guys. But that is not the question. Is asking us to find out. It is a volt per meter. Is asking us to find out its magnitude. This is the electric field at a point P. Is asking what is the magnitude of the electric field at a point P, which is equal to square root of minus 172.7. Just is algebra. You no need to draw all these figures, isn't it? Just for to make you to explain the concept of the perpendicular distance. So in the exam, you no need to write all those things. Hope during the study of this formula itself, you should know how to decide that perpendicular distance. Check out this value. This value is turned out to be, my calculator is showing its value as 193.09 volt per meter. So go back to the options here. 193.09. 193.09. Yes, this one. So the option A is the correct. You can just discard this one. So there is a one more statement here. Point charge of minus 4.43 microcoulombs located at minus 3, 4, 1 to cause Ey to be 0, Ey to be equal to 0 at a point P. So at this point, Ey to be 0. Where is that? So what is at that point P? What is the Ey? This is the Ey. So we wanted to make this Ey 0. So what must be the charge at, for that to happen? So we are locating the charge at this point. So if I locate this charge at this point, Ey must be 0. Or if I locate this point at this point, Ey must be 0. So let us take the charge q. Here minus plus is given. So better you take some charge q and let us work it on that. So I'll take the charge q, let us try to find out what is that charge value. Is that plus 3, plus 4 or minus 4? So the charge q is at minus 3 comma 4 comma 1, minus 3 comma 4 comma 1. Okay, so at a point P, what is that point P? It is 6 comma minus 6 comma minus 1 comma 3. So because of this charge, it must introduce some y component. So that y component must nullify this one. That means here minus is there. Because of this one, there should be a positive y component. So let us try to find out what is the electric field here due to this point. So what is the electric field due to the point charge, which is given by the Coulomb's law? It is q divided by 4 pi epsilon naught vector by its magnitude cube. So which is equal to, what is the charge is unknown, that is what we need to find out. It is q divided by 4 pi epsilon naught vector 6 minus 3, it is 6 minus of minus 3, it is a 9 x cap, minus 1 minus 4, it is minus 4 y cap, minus 3 minus 1, it is plus 2 z cap, divided by square root of 81 plus 16 plus 4 whole cube. Clear? Pick up only this value, pick up only y component. So q divided by 4 pi epsilon naught, what is the y component here? Minus y divided by, what is the square root of this one? My calculator is showing its value as 110 to the power of 3 by 2. This component must nullify that one. So Ey, what is the Ey component of at P? Ey component at P is this one. So this must become 0. That means the point charge, whatever the Ey component it is introducing, it must be a y component, positive y component. Yes. So it is a negative y. So it must introduce a positive y component. That means it must be equal to 172.76 y cap. Isn't it? Because that negative y component is introduced by the line charge. So this must nullify that. So for that to happen, it must introduce the positive y component. So from here, I will not going to do this algebra, I will leave it to you. So check out this one. My calculator is showing its value as minus 4.43 microcoulombs. So here the two options are interlinked. So that also, in that way also the MSQs can be formed. So it is minus 4.43, not plus. Okay. So this is correct, this is wrong. Clear guys? Hope you have understood the question. Yes. Chalo. Let us proceed further. Here is a question guys, this is on the work done. Here is a numerical answer type question. Yes, it is a straightforward question, simple question. But you should know one property here to handle this one. Yes. So a non-uniform field, electric field is given, E is equal to yx cap plus xy cap plus 2 z cap volt per meter. The work expended in carrying 2 coulombs charge from point 8 comma 0.6 comma 1 to b 1 comma 0 comma 1 along the shortest arc of the circle x square plus y square plus 1, shortest arc, and z is equal to 1. Remember, the electric field is a conservative field. The work done between the 2 points is independent of the path. It is only dependent on the location of the initial and location of the final point. Okay. So here it is joules. So he has given some complicated expression, doesn't matter. You can think in terms of the straight line. Straight line is a simple expression, you will go into line expression, you can get. Fine. So what is the work done is asking. So what is the work done? Initial to the final, Q into initial to the final. What is the initial? It is the A, final is B, it is E dot dl. So it is 2 coulombs. Initial to the final, it is yx cap plus xy cap plus 2 z cap. It is dx x cap plus dy y cap plus dz z cap. So this one is y into dx plus x into dy after dot product plus this one is 2 into dz. This is the integration factor. You can write this one. I think not, there is no need even for this. It is dxy plus 2 into dz. So no even required for this integral. It's specially designed, special kind of field. That is a conservative field, I said. Yes. So the path doesn't matter. Anyhow, so it is. So this is. It is a xy. Right. Done. It is 2z. Substitute upper limit minus lower limit. Okay, guys. So what is the upper limit? What is the upper limit? It is from A to B. It is the upper limit for x and y is 0. It will become 0 minus lower limit is the product of these two things. It is 0.8. 0.8 into 0.6 plus upper limit minus lower limit, it is 2 into 0. So it will become a positive value. Check out this value. So my calculator is showing its value as 0.96 joules. So this is the work done. 0.96 joules. Clear, guys? Done? Chalo. So let us proceed further here. So here is a one more question. Yes. It is MSQ again. Let the potential field be, so V is equal to 2x square y minus z minus 5z in the free space at a point P minus 4 comma 3 comma 6. Options are given. Yes. Yes, guys. What is the first one? The magnitude of the electric field intensity. Okay, magnitude of charge density. So how do you find out the magnitude of the electric field intensity? Directly from the gradient relation. This is how the possibilities are there where the MSQ can be formed. So the E is equal to minus gradient of V. So this is a Cartesian coordinate system. So it is minus dou V by dou x cap plus dou V by dou y cap plus dou V by dou z cap. Done. So let me turn the page here so I can write down directly what is the electric field. Differentiation of that entire thing with respect to x. So it is a 4xy so this one is 4xy x cap plus differentiation with respect to y. So it is 2 x square y cap plus differentiation with respect to the z. So it is minus 5 z cap. So this one is minus 4 x y x cap minus 2 x square y cap plus 5 z cap. Units are volt per meter. Is asking what is the magnitude of the electric field intensity at a particular point. Point is also mentioned. What is that? Minus 4 comma 3 comma 6. So just substitute here of v plus dou square by dou y square of v plus dou square by dou z square of v. Done. Now here what we'll do, it is a second order differentiation, fine. So let us do directly. So what is the first time differentiation with respect to x for this? So it is 2, what is given is 2x square y minus 5z. First time differentiation is with respect to x, it is a 4xy. One more time differentiation, it is a 4y. So it is 2x square y minus 5z. First time differentiation is 2x square. One more time differentiation is 0. This one it is 2x square y minus 5z. First time differentiation is minus 5z. One more time differentiation is 0. So here del square v is equal to minus 4y. Not minus, it is a plus 4y. Okay, let me turn the page, or let us finish here itself. So then what happens to the rho v here? The rho v is equal to minus epsilon naught into del square into v. So it is a 4 into y. He is asking at a point, what is that? Minus 4 comma 3 comma 6. So the y is 3. So it is rho v is equal to minus 1 divided by 36 pi into 10 to the power of 9 into 4 into y. What is the y value? Y value is 3. Y value is 3. So what is this rho v here? So check out this one. My calculator is showing its value as 106.24 picocoulomb per meter cube. 106. It is a pico here. Okay, so this is correct. This is wrong. This is wrong. Anyhow, so that is how MSQs can be formed. Fine. Let us proceed further here, guys. Nowadays, it is a very important. You can observe the previous paper. There are more questions on the capacitor calculations, inductance calculations. Okay, it is clearly mentioned in the syllabus also. So we're going to take up one model here on the capacitance, coaxial capacitor. So it is a composite capacitor. Fine. So in the recent times, it is a trend. Anyhow, so let us first try to understand this one graphically. So it's not a big deal. Only thing is you have to you should apply the concepts of your network theory and the formulas what we have learned in the EM theory together. Fine. So that you can easily handle such a composite capacitor problems. A coaxial capacitor has a dimension A is equal to 3 mm and B is equal to 12 mm and the length of the line is 1 meter. The region between the conducting cylinders contains the 3 different dielectrics. Epsilon R1 is equal to 5 for the row ranging from 3 to 6. Epsilon R2 is equal to 3, the row ranging from 6 to 9, and epsilon R3 is equal to 1 for the row ranging from 9 to 12 mm. The capacitance is dash picofarads. So how is that? So it is the inner cylinder, this is outer one. this one is, this is having a inner cylinder is having a radius of 3 mm, and the first one is 3 to 6 mm, the other one is 6 to 9 to 12. One more thing, okay. So here between these two things, the region is filled with the medium epsilon r1 is equal to 5. Between these two things, epsilon r2 is equal to 3. Here epsilon r3 is equal to 1. So it is something like, here what is happening is the voltage. So here, so the charge will going to split among all these things. Yes. So they will going to have a same voltage. The voltage is same. So as the voltage is same, we can see as this as a series connection, isn't it? So what is the potential here? So here the signal is connected between these two things. So it is something like this. So the charge will going to split among these things. So it is as simple as the capacitors are in series. So when the capacitors are in series, the resultant is equal to 1 by C1 plus 1 by C2 plus 1 by C3, isn't it? So first we will going to find out what is the capacitance in the each capacitor, each one. So we can make use of this formula. What is that formula, guys? So it is 2 pi epsilon L by natural log of B by A. Okay. So the signal is connected between, the potential is connected between inner cylinder to the outer cylinder. The charge will going to split among all these things. The charge will remain, yes. So the voltage will going to split among them. I'm sorry. So the voltage will going to, as you are applying the voltage here, so the voltage will going to split among all these things. So they can be treated as a series connection. Yes. Fine. So we'll take one at a time. So the C1 is equal to 2 pi epsilon naught epsilon r. What is epsilon naught? Epsilon naught value is known for us. It is 8.85 into 10 to the power of, it is 8.854 into 10 to the power of minus 12 into epsilon r value is, epsilon r1 is 5 into 1 divided by natural log of b by a. What is the b? 6 by 3. So the C1, check out this one. My calculator is showing its value as, yes, the C1 here is 400.91 picofarads. So that is the C1. That means capacitance between these first two regions. Similarly, C2, C3. So let us try to find out the C2. The C2 here is 2 pi into 8.854 into 10 to the power of minus 12 into, it is a 1 meter length, overall length. And what is this epsilon r2? Epsilon r2 is 3. 1 divided by natural log of b by a. So what is that? It is a 9 by 6. 9 by 6. So check out this value. My calculator is showing its value as 411.22 picofarads. Similarly, C3, so which is equal to 2 pi into 8.854 into 10 to the power of minus 12 into, what is the epsilon r? Epsilon r3 is 1. It is a 1 into 1 more 1 length divided by natural log of 12 by 9. So the C3 is equal to, my calculator is showing 193.19 picofarads. So as they are series, they are connected in a series. So what is the C equivalent? 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So the C total is equal to 1 divided by 1 by C1. What is the C1, guys? So 400.91, everything is in pico plus. So the resultant will also be in pico, just I am avoiding that. So it is 411.22 pico plus 1 divided by, so 193.19. So nowadays it is a very popular. So check out this one. I'll directly give the value. Okay, this algebra you can handle. So it is 98.99 picofarads. Okay, guys. So nowadays it is a very popular. There are more and more questions on that inductance calculations and capacitance calculations. Okay, go through all the formulas. Done. Let us have one more question here. So this is again MSQ. And in a infinite surface charge, an infinite surface charge 10 z cap ampere per meter floats on the plane y is equal to 4 meters and y is equal to minus 4 meters in the free space. So the options are given here. So let us take some diagram here. So there are two, what here the question here is, there are two so this is x, this is y, and this one is z. Okay, so where this infinite sheet is located, infinite sheet x, y is equal to 4 meters. Yes, so the current is flowing in the z direction. It is the infinite sheet, current is flowing in a z direction like this. So if I put my thumb like this, my fingers will going to show the direction of, let me use the above one. So I'm using this one. So it is a plus 4, it is minus 4. So for above one, I'll use this color, yellow color. Yes, if I put my thumb like this, my fingers will going to show the direction of magnetic field like this, here like this. So the magnetic field is like this and like this and like this. Okay, so for the below one, guys, if I put my thumb like this, so the magnetic field is like this, here it is like this. So in between it will going to add up, outside it will going to cancel out. So come back to this one, what did I say? A magnitude of the magnetic field intensity between the sheets is 0. Yes, in between it will cancel out, correct. The magnitude of the magnetic field intensity between the sheets is, no, it is wrong. This is a wrong one. Next, the magnitude of magnetic field intensity at y greater than 4 meters. That means outside, that is 20 ampere per meter. What is the magnitude formula? What is the magnitude of the magnetic field intensity due to this one? It is a k by 2. Yes. So here this is a formula. What is that k? That is the just magnitude we are taking. So it is a phi. So this is a magnetic field due to each sheet. So here is asking for y greater than 4. It is at that side. So it is getting added up. So that means it is a 2h, which is 10 ampere per meter. But what did he say? 20. So it is wrong. Next. So the magnitude of magnetic field intensity at for y less than 4 meters, that means this side is 0. It is a wrong statement. So it will going to get added up. It is a 20 actually, not 20, 10. Anyhow, guys, so this is how the MSQ can be formed. Here is a one more MSQ. Yes, guys. So let us proceed further. So this is also based on the formula. This is also based on the formula. What is that formula? A filamentary current of 5 amperes flows in the circular path with a radius of 1 meter placed in the free space. Okay, so there is a current loop. He is asking what is the magnitude of the magnetic field intensity at the center. He said 0. No, it is not 0. So what is the magnetic field? Suppose if there is a, it is a circular loop. This is having a radius A, this is a B. So what is the magnetic field away from the center? H is equal to I A square divided by 2 into A square plus B square to the power of 3 by 2. This is a formula. Okay, guys. So he is asking what is the magnetic field? He is asking what is the magnetic field. What is the first statement? The magnitude of the magnetic field intensity at the center is 0. Wrong. Center in the sense if I make B 0. If I make B 0, there is a formula. H is equal to I divided by 2 into A. Here is the thing. Yes. So what did he say? It is 0. It is the wrong one. It is not 0. The magnitude of magnetic field intensity at the center is 2.5. Let us check. At the center is 2.5. Is that true? So it is 5 amperes is flowing. It is 2. The radius is 1. It is given. It is 2.5. Correct. Ampere per meter. So this is correct. Next, the magnitude of magnetic field intensity at the axial length of 1 meter. Yes. The magnitude of magnetic field intensity far away point from the center of the loop is 0. So second one is H is equal to, what is that point? H at 1 meter. So it is, everything is 1 here. So it is a 5 into 1 square divided by 2 into 1 plus 1, it is 2 to the power of 3 by 2. Yes, so it is 5 divided by, so this will become 1 more 2, that means you need to add, it is 2 to the power of, it is 2.5. 2 to the power of, let me check out this value, I don't have. So it is 2 divided by 2.5, 5 divided by 2 to the power of 2.5. Am I correct? It is 0.88. 0.88 ampere per meter. But what is given in the question? .7. So it is wrong. Next, the magnitude of magnetic field intensity at far away for the point from the center of the loop is 0. If you go to the very far away point, yes, far away point in the sense infinite point, let us say, if the B tends to infinity. For example, if B tends to infinity, so what happens? Obviously, anyhow A is fixed as B tends to infinity, that leads to H leads to 0. Correct statement. So this is correct. Option D is correct. Okay, guys. Chalo, let us proceed further. Yes, here is a question. It is a MS numerical answer type question. It is a very popular. So we have done one question on the Gauss law, one question on the Ampere's law I am going to do. So you have to understand how important. So as far as our exam is concerned, there is a Gauss law, Ampere's law, electric field due to the various charge distributions like a line charge, surface charge, and magnetic field due to the various current distribution. These are important topics. Okay, guys. So how I am saying that they are important? From the previous papers, that's it. Okay. So observing the previous papers. So the magnetic field intensity is given by, so this is a magnetic field intensity in the free space, okay. The magnitude of the current density at a point 1 comma 0 comma 1 is, so what is the current density, guys? A very popular question this is. J is equal to a del cross H. The only thing is you should know the formulas in all the three different coordinate system. Don't limit yourself only to the Cartesian. In the recent times, the questions was noticed even from the cylindrical and spherical. In the electrical paper, that was not earlier case. In the earlier, we used to have questions only from the limited, confined only to the Cartesian. Okay, so you must be careful with all the formulas. You should know the formulas: divergence, curl, gradient, Laplacian operator, differential length, differential surface, differential volume in all the three coordinates. Okay, guys, fine. So let me write down the formula here. So the formula here is 1 by rho into rho cap, rho into phi cap, z cap, dou by dou rho, dou by dou phi, dou by dou z, h rho, rho into h phi, hz. So just substitute all the values properly here. So this is 1 by rho into rho cap, dou by dou rho. What is h phi? It is 3 by rho. So this is rho into phi cap. It is dou by dou phi. So the rho is multiplied with this one. So it is 12 into rho z minus phi. Yes, so it is z cap dou by dou z into hz. What is hz? It is 2 rho square sin phi. So perform the determinant here. Fine. So let me turn the page here. So this one is 1 by rho into rho cap into this minus this into this. So it is 2 rho square cos phi. This into this is minus 12 rho. Am I correct, guys? Yes. Minus 12 rho. Minus rho into phi cap. Done. This into this minus this into this is, it is 4 rho sin phi. This into this is minus 0 plus z cap into this into this is, it is 12 z minus phi. Minus 0. So this is j 1 by rho into 2 rho square cos phi minus 12 into rho cap plus, not plus, it is a minus 4 rho square sin phi cap 12 z minus phi into z cap. Done. So it's asking at a point at 1 comma 0 comma 1. That means it is rho comma phi comma z. So just substitute all the values. So this is 1, this is 1, this cos is, this is, so it is 2 into 1 into 1. So this is 1 minus 12 into rho cap. So this is 0 minus this one is, so it is minus, z is 1, so it is 48 z cap. Done. So this one is minus 10 rho cap minus 48 z cap. It is asking for the magnitude. So what is this j magnitude, guys? The square root of minus 10 square plus minus 48 square. So just go through this algebra. So my calculator is showing its value Let me check out the value here. Yes. So let me check out this value. So it is 100 plus 48 into 48. It is 2404. It is 49 ampere per meter square. Such a huge current. Anyhow, 49 is the answer. Okay, just go through the numericals here. So let us take something interesting one. So here is a question, something related to the inductance calculation. So the mutual inductance calculation. It is not a regular your circuit theory question, something different. Okay, an infinite filament carrying 2 amperes lie along the positive z axis in the free space, and a square coil turn is of 100 turns lies in the y is equal to 0 plane with its corners at 1 comma 0 comma 0 2 comma 0 comma 0 2 comma 0 comma 1 1 comma 0 comma 1. The mutual inductance between the filament and the coil in microhenry is something interesting. Okay. Okay, done. So let us try to solve this one. Yes, guys. So the mutual inductance, how can you obtain the mutual inductance? So you need to find out how much is the flux induced in the coil due to the infinite line. Fine. So then from there you can find number of turns into the flux linkage due to the adjacent one divided by the current. That is formula remains the same, but let us take the coordinate system properly. So then the integration will become simple. So let us take the coordinate system. So where this it is placed on the z axis. So let me take this as a, this is a x, this is a y, this is a z. So the infinite line current is located here. On the z axis. So the current is flowing in the lie along the, if nothing is mentioned, you have to take it as a positive z direction. A coil, square coil of 100 meters lies in the y is equal to 0 plane with its corners at 1 comma, where are the points here? 1 comma 0 comma 0, 2 comma 0 comma 0 comma 0, and other one is 2 comma 1 comma somewhere here, and other one is 1 comma 0 comma 1 somewhere here. So let us make some. So this is a coil, guys. He is asking what is the MMF, not sorry, it is the mutual inductance in this coil. So the coil dimensions are given. What is that? It is, what is that point? 1 comma 0 comma 0, this one, 2 comma 0 comma 0, this point, this point is 2 comma 0 comma 1, this one is 1 comma 0 comma 1. So how much is the flux crossing through this one? Differential area is, it is y is equal to constant, it is a dx dz. This x is a perpendicular distance. Okay. So we'll find out how much is the magnetic field. What is the magnetic field due to the infinite line current? It is mu I by 2 pi rho. What is the perpendicular distance here? The perpendicular distance is the x. It is a mu naught. So this one is 2 into mu naught divided by 2 pi into x. So, which is mu naught into pi into x. So, this is a flux. So, find out the magnetic flux here, surface integral of, after dot product and everything, B into dA. Yes. So, it is a surface integral of mu naught into pi into x. So, which is dx into dz. So, separate out the variables here. So, this is mu naught by pi. So, it is 1 by x into dx. This is dz. Perform the integration here. So, mu naught by pi, it is natural log of x. X limits are ranging from 1 to 2. This is z. Z limits are ranging from 1 to, this is from 1 to 2. This is from 0 to 1, sorry. Substitute upper limit minus lower limit. I am going to turn the page here so that you will going to get the flux linkage. So, the magnetic flux is equal to, so it is mu naught divided by pi into natural log of 2, upper limit minus lower limit, into 1. So, check out this value, psi m is equal to 4 pi into 10 to the power of minus 7 into natural log of 2 divided by pi. So, the magnetic flux, it will going to give, just keep this one as it is. So, once you have got a magnetic flux, keep this one as it is like this. So, psi m is equal to mu naught into natural log of 2 divided by pi. So, the units are Webers. Let us define what is called a mutual inductance. How do you define the mutual inductance? So, how many turns here it is mentioned, number of turns into the flux linkage due to the, this is a flux due to the line in the coil we are finding. So, that is the reason why it is a mutual inductance, fine. So, the number of turns in the coil into the flux linkage due to the line divided by current flow. Okay. Yes, you can just substitute all the points here. So, what is the current? It is the 2 amperes is flowing. Yes, you can substitute all the values here. So, it is 4 pi into 10 to the power of minus 7 into natural log of 2 into 100 divided by 2. Okay. So, this will become into the pi. Don't forget there is a pi. Just a second. Let me correct myself. Here it is 100 divided by 2. Yes. Into the flux linkage is mu by pi into natural log of 2. So, 50 into 4 pi into 10 to the power of minus 7 into natural log of 2 divided by pi. So, this pi will go, it is 200 into 10 to the power of minus 7 into natural log of 2. Yes. So, is asking in the micro. Okay. So, this will become, let us check this value. Let me check out this value. So, this is 200 into natural log of 2. So, it is 138.62 into 10 to the power of minus 7. Is asking in milli. So, you can bring that two things this side, milli or micro. Is asking the micro in micro. So, it is 13.862 into 10 to the power of minus 6. So, which is 13.862 micro Henry. So there is nothing new in this subject actually. It is an integral part of your entire electrical engineering. So in this subject, we will be talking about what is called a charge, current, electric force, magnetic force, Lorentz force, inductance, capacitance, isn't it? Faraday's law. All these are very much familiar with you guys. So the knowing more about electromagnetic fields will going to help you in either way. One thing is you can handle with the questions in the exam. The other thing is it will going to help you in understanding your electrical subjects in a much more deeper way. Okay guys, anyhow, so we had a wonderful session on the day of New Year. So I'll wish you very success and growth and everything in your life. So once again, Happy New Year, all the best, good luck for your preparation and exams. Thank you.